Hey everyone, welcome back. Today we are diving deep into a fundamental part of memory management, how malloc and free work. Even though we are usually coding in C++ on this channel, it's important to understand these C-style functions because they are building blocks underneath the abstractions we use every day. Let's get started by thinking about how memory is organized. When a program runs, memory is typically divided into several segments. There is the stack, the heap, the text segment, and the data segment. The stack is used for static memory allocation, like when you declare variables inside a function. The heap, on the other hand, is where dynamic memory allocation happens, and that's where malloc and free comes in. Now, what does malloc actually do? The function malloc, short for memory allocation, is used to request a block of memory from the heap. The syntax looks like this. Here we are asking the system to give us enough memory to store one integer. Let's think step by step about what happens internally. First, when malloc is called, it checks if there is a block of free memory big enough to satisfy the request. If there is, it reserves that block and marks it as in use, then returns a pointer to the start of it. If there isn't enough memory available, malloc returns a null pointer. Now notice that malloc does not initialize the memory it gives you. The memory could contain any random leftover data. It's purely raw memory. In C++, we usually prefer using new, but behind the scenes, the memory allocation part of new often ends up calling malloc or a similar low-level function provided by the operating system. Okay, but now that we have dynamically allocated memory, we also need to be responsible for freeing it when we are done. That's where free comes in. Let's say we have this code. We can later call this. It tells the system, hey, I'm done with this memory. You can reclaim it for future use. Internally, free takes the pointer you pass it, finds the metadata that malloc stored, usually just before the block you received, and updates its internal bookkeeping to mark that block as free. If you forget to call free, you will cause a memory leak. That means the program holds onto memory it doesn't actually need anymore. Over time, especially in long-running programs, memory leaks can add up and cause the system to slow down or even crash. It's equally important not to double free memory, meaning don't call free on the same pointer twice. That can corrupt the heap structure and cause undefined behavior, which is often very difficult to debug. Here is an example of proper usage. Notice how we check if malloc returned a valid pointer before using it. That's a good habit. Now, there is one more thing. Once you call free, the pointer you had still exists, but it points to memory you no longer own. This is called a dangling pointer. A good practice is to immediately set your pointer to null pointer after freeing it, like this. That way, if you accidentally try to use it later, it will be easier to catch the mistake, because dereferencing a null pointer usually triggers a clear and immediate error. So to summarize, malloc reserves memory on the heap. Free releases it back to the system. Always check if malloc succeeded. Always free exactly once. Set pointers to null pointer after freeing them. Understanding malloc and free is crucial, even in C++, because smart pointers like stud unique pointer and stud shared pointer manage memory safely, but underneath, they are built on the same ideas. Alright, that's it for today. I hope you now have a clearer understanding of dynamic memory allocation. Thanks for watching, and I will see you next time.